Hey, welcome back. Good to see you again. Hope you're all well. Thanks for joining the channel. And welcome back to the Rotel RX-1603, part 3 of this video. We're going to combine these two together and do some testing. But first I wanted to take care of some house cleaning. Let's see here. Got some viewer comments I wanted to respond to. I know I respond to some of the comments in the comment section, but there's some here I didn't, or maybe didn't do them good enough. I'm going to go through them again. John Boyle 1425 asks, or says, when or welder soldering iron would make quick work of the solder points on that tuning capacitor box. Most of my work is with older tube rigs, and I've used both of these guns for many years. However, a welder iron is used with printed circuit boards. Yeah, I do have the gun type soldering iron that we're all familiar with, and I do have, where is it? And I do have this monster 100-watt iron. I could have pulled that out, I guess, and used it. Probably would have needed to prep the tip first. But it was just a matter of, the torch was right here beside me. I grabbed it, hit it with a torch. Torch is fast. And yes, you have to be very careful with what you're blowing your flame on. You can't blow it on dial cords or wiring. And I know from the angle I shot the video, it looked like the dial cord was quite close, but I was blowing the flame away from it and directing it right on the tuning capacitor. So it was kind of laziness on my part, I guess. I just went for the quickest, fastest solution for that time. I do have those tools in stock here, and I do use them. The next comment comes from 10 Minute Tokyo 2643, and he says, "What a beast! Jam in modern LEDs." Yeah, okay. I would put LEDs in here, but it wasn't a customer request. I don't really like yanking out original lighting and putting LEDs and everything. It kind of goes against my idea of what a restoration is. I think the restoration is to try and keep it as original as possible, try and keep it looking as original as possible. And the incandescent lamps were working at that point. They had no problems. They were all lit. And the incandescent gives the proper color temperature, or the proper light temperature, or the color to the dial scale. So I just left it alone. Plus it's a cost thing too. Why rip out perfectly good lamps and replace them with other lamps, especially if LEDs to me aren't really a proven, well, I shouldn't say that, they are proven, but LEDs can fail just as well as incandescent lamps. So I don't see any advantage of putting LEDs in over incandescents. They're both going to fail eventually, and you know, it's just a matter of economics too. So let's go to the next question here. We got Jeff Candy 2479. How come everybody's got numbers after their names? Jeff Candy 2479. He said, "This is my favorite vintage audio restoration and Alberta accent channel on YouTube." Well, thank you. I didn't know I had an Alberta accent. If you go farther east to like Manitoba, yeah, those guys have accents, but not Albertan. Come on. So informative. You deserve far more subscribers, sir. Well, thank you. I appreciate the comments, and I appreciate your support. But that's a good one, the accent. Yeah. Time for Tacos said, "Trevor, how strong is the resin UV repair versus normal super glue or super glue plus baking soda?" Well, all we need to do is hold that pin in place. The UV resin was just there to hold it. I could have shoved the pin back in and it would make connection, but eventually over time I have a feeling with heat cold cycles, you know, that pin could work its way back out, and it could, maybe 10 years, maybe it could fail again. So the UV resin was just there to plant that pin and keep it from backing out under normal usage. It's not a matter of strength, it's just a matter of blocking it from coming back out. That socket's fine. It had the connectors to the transistor are fine. There's not any problem with that. And another thing is, I've never used super glue and the baking soda technique some people use for building up plastic structure or whatever. I've never done that, so I don't know anything about it. So it'll be something I'll learn in the future. But yeah, it was just a matter of anchoring that pin so it didn't move. And then he says, please get a YouTube music tune to play on this amp. And he says, after 3 hours we need to hear it play music. Well, I don't have any speakers in this room that can adequately do this thing justice. So that's why I really don't like playing music on my bench. I really try to avoid that. If I'm gonna do a demonstration of a turntable or a receiver or something like that, I'll make a separate video and I'll try and get it set up properly so that it, you can actually hear what it sounds like instead of just room acoustics or my crappy bench speakers, how they sound. They're terrible right now. I got one that's got a broken voice coil and it's buzzing and rattling. So yeah, I don't really have facilities for doing music tests like some YouTubers do, and that's the reason why. And there was one comment that I had that I couldn't find I couldn't find it on my in my email. It came in my email, but I read it and I didn't answer it. It was from a viewer, and he said he was concerned that I use steel for these brackets to hold this antenna in place. He says, wouldn't that affect the reception? And my answer is no. The bar antenna is a ferrite core, a ferrite bar in here wrapped with a coil, and it's in this plastic tube, and this is what picks up the AM signal. This part here is just mounting, and it really isn't interfering with the ability of this antenna to pick up any signal. So this being metal or plastic doesn't really make any difference. So that's that. Alright, well, thanks for your questions. I always try to answer the questions in the comments, and if I don't get a chance to, it's because I'm busy or other things come up. But yeah, I appreciate your guys' comments and questions. I really do. So let's put these two together and see if we can make it work. Okay, putting these together is pretty simple. First step would be make sure these big power supply capacitors are discharged. And then you don't want to be putting any currents through here where it doesn't need to be. Okay, so there's 3 connectors at the back here. You can see them. They all have different pin numbers. If you put them together, you can quickly identify which one's the longest, which one's the shortest. So there we go. There's the shortest one. Let's take the shortest one and plug it in here. And it's keyed. It only goes one way. That one there. And then the next one, we put these two together. That's the next shortest one. And this one goes here. I can't really see with my big hand in the way. I'm going to come from this way. Okay. They're not very good connectors and they're pretty flimsy, so be careful with them. And then the longest one goes on the last. And make sure they're seated. Okay, that part's done. Now we bring in the power connector. There's 2 connectors. It's pretty self-explanatory how this goes together. The female goes onto the male connector here. Make sure it's bottomed out, and then plug this one in here. There. That's all there is to connecting them together electrically. And then we take the head unit and move it back, because the head unit's lighter. Move it back into position. And you have to be careful that we don't pinch any wires. We put this together. So this channel here is going to go inside the heatsink. And we need to get, there we go. Looks like our heat sinks are a little bit too close together when I put them. I might have to loosen some of these screws on the bottom just to get this heatsink to come out a little bit. I got like 1/2 millimeter. It's just catching on the, unless I can wiggle it in. No, it's not going to work. I'll have to adjust this one or the other. I'll have to move this out a little bit. Okay, so I loosened 3 of the 4 bottom screws, and then I should be able to get a little bit of slack here. And I do have room now. I can slide the 2 together. There. Now we need screws. So the screws we're using are M4, black M4 screws, and they are, let's get it into millimeters, they are about 15 millimeters long, okay? I don't think they need to be that long. The 10 millimeters will work. But there's 3 screws on each side. We're just going to put these through the heatsink into the back bracket. And there's 6 screws, 3 on each side. We'll just snug down. I'm not putting all the screws in. I'm just going to do it temporary just for this testing. And there it is together. So I have a couple screws on each side. Now, I think the main importance you want to have these coupled and screwed together is because there is no ground wires, or I don't think they're adequate. You need chassis ground to be connected, and the only way to get chassis ground is connect these two together and use a screw. That way this is properly grounded to this. And yeah. So, this thing's pretty huge. Once it's together, it's near impossible to manipulate and turn around and flip over up on its side. So I'm going to leave it like this for now. I think this is the best way to test it, because I have all my output connectors on this side. My input connectors are in the middle. I have controls on the right I can access. Don't really need to get on this side for any reason other than, I don't know, don't think I need to go that way. Not going to get caught by you today. Alright, I think I'm ready. I have connected to power. You can see the watt meter here. And everything's set up on the controls except for the speaker switches. I got FM auto selected and everything's set flat. So let's just turn it on and see how it goes. Now, when I was testing the power amplifier, I wasn't getting the soft start circuit kicking in to provide full power to the amplifier, because I have a feeling it feeds from this supply here. Feeds plus minus 75 volts to this supply, which regulates it down to 35 plus minus 35 volts in the head unit, and then sends it back to the power unit for use. So let's turn it on, see what we get for lighting. Pay attention to the light and the click. So here we go, fire in the hole. And we still have nothing. So we got a problem. Shut it off. We're 54 watts and that relay is not clicking in. So we have to investigate why that is. Let's try it one more time. It's slowly coming up, but it's still not doing it. I'm wondering, let's check the voltage on the capacitors. We're down to 11 volts. Okay, let's turn it on one more time. I just don't want to smoke those resistors in the soft start circuit. So let's go one more time, and I'm going to monitor the voltage here. You can't see it. I'll put this down so you can. There we go. Okay, if I can hold these, and then we'll switch it on. We're only getting about 80 volts. What I'm thinking here is I'm thinking of adding another 100 ohm resistor to drop the resistance down to 50 ohms overall. And we'll see if that brings it out of soft start, because it doesn't seem to have enough power to get over that hump of charging up the capacitors. There's still too much load on here to overcome. So let's try that. So what I have here is a 100 ohm 10 watt resistor, and what I'll do is I'll just tack that on the back of the board and we'll use it as a test. Okay, so I got that 100 ohm resistor tacked in there, and effective resistance right now is 50 ohms. because I did measure it before I tacked it in, and the two 200 ohm resistors equaled 100 ohms in circuit, and then I put another 100 ohms on top of that, so we've got 50 now. So let's turn it on, see if it clicks on. It's still struggling. Beginning to think we may have a problem in our power amplifiers. It's going to be drawing heavy current. What does our voltage go up to now? Let's see. Okay, let's test our rail voltages one more time. Okay, here we go, going live. 95, 100 volts. Still not doing it. Now what I'm trying to determine is if there's a short somewhere in this receiver or this power amplifier, but the schematic and service manual that's up on Hi-Fi Engine's fairly poor quality. Now I got to hand it to the guy that scanned it and put it up on Hi-Fi Engine. Thanks for doing it, but it's missing pages and it's unreadable in a lot of cases. So I'm trying to determine how power gets from here to this regulator module here, and it's not really clear. I think I'm going to have to start following wires because I can't decipher the wiring diagrams that Rotel gives. Now I have two regulators here, positive and negative, and they are plus minus 35 volts, right? So let's have a look at the power coming in or going out of these ones. If I can find a spot here where you can see this. Let's I got my one probe on ground, I got my positive here. Let's check the collector on this one. We got half a volt already. So let's turn this on. And it goes up to 38, 39 volts. Okay, let's check this one. 31.5. 30.8. Okay, let's check the collector on this transistor. And we get 19. See, there's something going on here. 19. 20. So we might have a short on this rail. Ooh, smoke coming from here. Yeah, so that's our problem. We got a problem on the power board. So let's get a look at what's going on here. We have a short and resistors are heating up. It smells like resistors. It smells like hot resistors. So yes, we have a problem here. Let's separate the two, flip this over, and try and fix this. Okay, flipped it over and I already see the problem. I don't know if you can see it too. Let me show you. It is one of my cock-ups again. Let's zoom in. I don't know if you can see it. Maybe you can start to see it. Maybe you can start to see it. Look at this capacitor here. It's bulged and it's installed backwards. The reason is the dot is your negative, and I put the dot, the negative, this way to this dot, but that cap is in backwards. Wow, surprising that's got to get away on me like that. So that's a 220 at 50 volts. I'm going to replace that, and yeah, that one's garbage. Oops, look at that, it's popped open. It bloated. Well, there you go. It wouldn't be any fun if we didn't have any screw-ups in those smoke shows, right? So that's the cap I put in there. It's a Camet 220 50 volt 105C. It blew its top. Let's see what it measures now. See how badly destroyed it is. Here's negative, positive. Ooh, so we're down to 145 microfarad, 50 milliohms, 500 milliohms, sorry. Let's put a new one on and see how the new one compares. Here's a new one. Yeah, a little better. We'll put this one in and we'll See how she does. Okay, we're back and we're going to put this through another test. Here we go. Come on, cooperate. Okay, here we go. Going live. Haha, it's working. Okay. So, let's engage the speakers A. Wow, that's a loud relay. That's stereo, both channels. Okay, let's do a thing through the band. Let's connect an antenna first.
Quand j'avais des auditions ou...
I know exactly what you're talking about. Doesn't sound like this, though.
Seems like the tuner's working pretty good. Pretty weak stations. We're not getting much on the signal strength meter. Until we get to the top of the band, you'll see it deflect a lot more. Sounds good.
Fine.
It's between spring of this year and now.
Yeah.
Let's find out. Did Gnome just...
Yeah, antenna would really make this thing shine. Get into the stronger stations here. Comes in clean.
Easy, we dressed up.
Okay, let's try AM. Get our antenna up in the air. That's what it's for. We have nothing on AM. Oh, that's interesting. Nothing at all, eh? Okay. What is going on with their antenna? Yeah, we're not picking up any AM. It is working, but we're not picking anything up. So there's something wrong with the tuning, not the tuning, but the antenna part of it. So we're going to have to troubleshoot that. We're consuming 118 watts. Is that correct? That is a lot of power. Where is all that power going? This heatsink down below here is quite warm. These are still cold. I don't feel any heat coming out of here. There should be 100 and some watts. You'd be able to feel that heat. Okay, let's check phono. Getting some hum. That's normal because shields are off. I don't hear any rumble or any noise from any components right now. Sounds okay. Check. Okay, so that function's working. When I turn all three on, 1, 2, 2, 1, 2. Put the third one, it does nothing. Okay, that seems to work fine. Let me feed a tone through here. What I'm going to do is adjust the bias one more time, because now that we have full power coming into the amplifiers, we can tweak up our bias adjustment. So I think it's between this connection here and this pin. Oh yeah, look at that, we got 49 millivolts. It's way too high. Let's turn this down. Let's turn it down a little bit. We wanted 30. I'll put it a little bit on the low side, 28. Okay, let's do the other channel. Oh, 65, that's even worse. No wonder it's consuming 110 watts. The bias cranked right up. It's been on for about 10 minutes now. So let's take this down. 28. 28's good. Now what are we at? Oh, much better. We are at 72 watts, 73 watts, around there. Minus the 18 for the lamps. That puts us down around, what, 55 watts or so for the two power amplifiers idling. That's about normal. So I'll just let this sit on power for a while, and I'll come back and I'll check this bias again. Okay, what I've done is I removed the 100 ohm resistor from the soft start circuit, and I want to see how the voltage climbs up on the stock resistors. So we have the original factory setup. Let's turn it on, and I've discharged the main capacitor, so there should be no influence from that. So let's turn it on. And it had a little bit of a noise there. Ooh, that was the AM. So it's discharging, turning it on. Wow, big pop on the AM dial. Let's try FM. Okay. Alright, let's try and sort out this AM tuner. So we have, well actually this sheet here is showing the front end for both AM and FM. So everything here, this part, this part, this part, this part, ignore all this. We're only concerned with what goes on here and here. So the AM input for the antenna comes in on a red wire, goes into the loop stick antenna, and it's a separate coil, and it goes to ground. So any signal that comes in here is induced into this it's like a transformer rather than an antenna stick. Well, it's an antenna stick and transformer. So any signal that comes in is induced into this antenna. That's what the purpose of the AM antenna is, and it's all isolated from everything else. So if you have a lightning strike or something, it's not going to damage, or shouldn't damage anything internally. Then you have your loop stick antenna. I call it a loop stick, but it's just a ferrite rod with a transformer on it, coils. The green wire is grounded, okay, and then the white wire goes up through a choke and to the tuning capacitor. This is the tuning capacitor, this is the trimmer capacitor. So depending on where on the band this is, determines the how this tank circuit kind of is tuned. Oops, sorry. Now this capacitor and this capacitor tunes the antenna, the input, antenna input for maximum gain and maximum signal. I think it's yellow wire. This is the wire that feeds the signal into the tuner at pin 10. Now there's also going to be not sure, they got 12 and 13 here, and these are all tied together, these 6 capacitors, 3 capacitors and 3 capacitors and 3 trimmers. They're all tied together by the mechanical tuning shaft. One of these is going to tell the oscillator what frequency to oscillate at. So possibly we have a failure somewhere in this secondary side of the coil, where we might have an open or a short. We might have a short here, here, or here. It's hard to say, but for whatever reason it doesn't seem to be tuning. Signals are getting in. Let's connect the signal generator and feed some signals in, see what we can get. Alright, got the signal generator running at 600 kilohertz, fairly strong signal, it's modulated, and I run it through this loop antenna, and I'm just going to place this over the our loop stick, and place things so it doesn't short out, and we're going to pump a signal into this thing and see what we can get out of it. So turning on, here we go. Let's tune this to 600. Let's turn up the volume. You can barely hear it. That's full volume. And I'm tuning just off of 600. Let's go down the scale. Nothing. Up the scale. Ooh. Okay, so we're getting nothing on the band whatsoever. Let's try 455 kilohertz. Okay, that's at the bottom of the band. Kind of disappears as we go up. Nothing whatsoever. So let's put it somewhere in the middle of the band, like 800, and let's scan up and down with the signal generator, see if we can lock in a signal that comes, find a spot where the signal comes through. So I'm at 455 now. I'm going to start climbing up the band, and I'm gonna. Okay, there's 458 kilohertz. It seems to come in a lot stronger. So it seems like our IF frequency is 458, not 455 for some reason. So that might be out. Okay, let's go back to 800. Let's go up in frequency. $500. 600. 700. We're getting close to 800 here. Let me turn the volume up a little. 800. 818, I get a little twinge of signal. 851, I get another little twinge. 938. 1 megahertz. 1100 kilohertz. Oh, there's a fairly strong signal there. Let me see if I can center in on that one. So that's 1156 kilohertz. megahertz, 1300 kilohertz, 1400, 1500, 1600, 17, 18, 19, 20. So yeah, there's nothing there on the band. And we picked up a signal at 1160 some kilohertz. Let's go back down. It didn't go down. There's 461 kilohertz right there. .458 kilohertz. Let's go down. I'm going the wrong way. Let's go the other way. Nothing. Now 300, 200 kilohertz, 300. Nothing. Nothing, nothing, nothing. So this tuner is definitely messed up. I'm wondering if it's the local oscillator is running at a weird frequency for whatever reason. But it's not picking up a strong signal. I'm pumping a really hard signal into this thing and it's not picking it up. It's coming in weak, and you have to determine what's going on with that. I'll try the same thing up here on the top of the band. Let's get 1500 kilohertz. Let's try a signal around this part of the band. Same thing. Okay, that's 1157. The same spot. It seems like there's a window there at 1157 where the signal's getting through. It doesn't matter what frequency I give it, it seems to come through at that 1157. Let's go higher. So I'm at 1200, 1300, 1400, 1500, 1600. Where are we at here? Okay, right here. This is 1637 kilohertz. And we are tuned in at 1500 on the dial. Two megahertz, nothing. Okay, let me do some thinking here. Alright, I think I might have found the problem here. I was just doing some continuity checks on these two lines that come out on pin 12 and 13, and they go through these capacitors to ground. So these should not be grounded. This line here and this line here. So I checking on pin 13. Now this is 12 up here. This reads 12. It's awfully dirty. So if I check on 12 to ground, I'm getting about 600 ohms, 700 ohms. Okay, and if I pick 13, I get an open circuit. But I've disconnected the wire. Now if I check the wire to the capacitor, if I check here, we got 0 ohm short. So that's my problem, is I have a 0 ohm short on this line for pin 13. Pin 13, cut the line here, and these two capacitors should be open, but they're not, it's shorted. So we have to open up that tuning capacitor to see what's going on inside that causes this short. Hopefully it's something simple. Okay, the short is in this middle gang of the middle capacitor here. This one here. Okay, that should be grounded. The brass rod should be grounded. That's correct. But if I test the other end, the plates, there's also a short on these. And it's not the plates touching, because when I fully open it, the plates should be disengaged from each other, and it's still there. So if I touch here, and I've cranked down on this little trimmer capacitor, backed it off, didn't make any difference. So this short is internal. I'm gonna have to take that cover off again. I don't know, maybe a solder splash went down inside and is causing havoc, but I'll take that cover off again and we'll see what we can do about that. Okay, I just realized my mistake here, and I see where the problem is. I don't know if you can see it too. Let me get some wires out of the way here. There's 3 windows here, 1, 2, and 3, for the 3 AM capacitors, the 3 variable capacitors here. This one has a solder lug, this one has a solder lug, this one doesn't. It looks like that solder lug is bent over, so I'm going to see if I can dig that out of there. Looks like when I put the lid on, the lug got bent over for whatever reason. Can't. If I push it from this way, let me try pushing it. It's definitely what the problem is. See? I got trapped again by one of these little. Ba-doink! There, it's free. Can you see that? Let me straighten it out. Now, I'll bet you my short's gone. So let's test. Let's test. So, oh yeah, look at that. That short is gone now. Okay. Our AM should be working now. So let's do an alignment on the AM to get everything 100%. Okay, so the service manual on Hi-Fi Engine only has instructions for doing the AM alignment procedure. The FM procedure is missing off the website. There's no scan of it. So that's unfortunate. So we can't go there because I don't want to muck around with settings. I don't know what they do. But we do have for AM alignment, and there's 3 steps. First one is doing the 455 alignment, and then the next step is doing the 600 kilohertz, and then the last step is doing 1400 kilohertz. Pretty standard affair. So it wants me to feed a signal in through a 10 nanofarad capacitor, and I have 100 here. It doesn't really matter the value, it's just to block any DC. So I'm going to feed a 455 kilohertz signal into pin 12 on the board, and that's going to be modulated so we can hear it, of course. And then we're going to pick off a signal on the tape output jack so that we can monitor it on a voltmeter, and then we'll use that as our scale for adjusting. So I have everything connected, and I have a 455 kilohertz signal going here, but it's turned down. So let's turn on the receiver, and let's test the AM first, because I know it's working. It should be working now. So let's turn this. I'm still getting nothing. I wonder if everything is connected properly. Let me remove this. Let me remove this, and we'll see our tuner should be working. Okay.
Starting out.
Okay, it's working. We know it's working. So we gotta tune this to some place where there's no station between stations. Right there is good. Let's connect our input back in. Okay, give it a bit of volume, and then we start feeding it a signal. It's a fairly large signal going in. So I'm going to refocus you onto this voltmeter. That's going to be our scale, and I'll start adjusting. Here's L104. Okay, we got a little gain out of that one. Now we need L102. This one here. Okay, we got no gain out of that one. Let's do 104 again. Okay, that's maxed out. Let's turn this down. What I want to do is I want to sweep the signal frequency between 450 and 460, and I want to see where the center frequency is. So let's try this. Okay, going up. 456 really. Here's 459, 456, 455, 54, and then it goes down. I don't know why it's off that little bit. Let me try going again. Okay, that's peaked. 459 it really peaks. 455 it doesn't. That's odd. I wonder if we have a value capacitor, a value or something. Okay, next step. My signal generator is connected to this loop. This loop's placed over the antenna, and I'm feeding in a 600 kilohertz signal. And I'm going to monitor the voltmeter again. Let's see if I can get this cable out of the way so you can see. Now the receiver's tuned to 600, my generator's tuned to 600. I'll turn up the volume on the generator. And that's a very strong signal. Let's turn it down a little bit. We're going to adjust L103, L105 on the IF board, and L004 on the antenna coil. So let's do 103 first, which is the OS coil, I believe. I'm going to turn these down. Okay, you got a huge gain out of that. Go to the next one. Same thing. There's a lot of gain to be had by tweaking this. Let's turn down the noise. Wish I could do this. Maybe it's more pleasing for you guys. Peaked. I'm going through them again. I think that's good for both. And that's at 600 kilohertz. Now we need to do the loop antenna. I need a screwdriver. Huge. Turn this down some more. You see we're getting into the noise now. We're getting my signals going down. Okay. Now we're going to do the last step where we tune the signal generator to 1400, the receiver to 1400, and then we adjust these four here, or three, capacitor 7, 5, 6, and 7 on a tuning capacitor. So let's go through this, and what do we need to do first? CT7 is the oscillator. CT7 is the center one, that's the one that was shorted. So let's adjust this one till we get our signal. Right there, it's peaked. Okay, let's do peaked. And the last one. They're all pretty good except for the center one, which I was fumbling with. Oops, I knocked it. Right there, I think. Turn down. We're getting interference. There we go. We'll leave it at that. So that should be it. Our AM's all tuned in. There's a little spin through the band. See how it's working.
हवाई हमले कर रहे हैं तो इस तो पहला हमास वालों
homestand for the Oilers. Of course, Sunday it's the Heritage Classic.
people who go to your kids' schools, these are people who are in your community.
All the stations are coming in.
The war in Gaza continues. They're sending a letter to Premier.
And then once I get past 1 megahertz, it's just all hash and noise. What station is that? Is it 1450 or so? Okay. AM's done. What I'm going to do is I'm going to go through and just kind of tweak up the FM a bit. I'm just going to check dial accuracy, basically. And if I see it's out quite a bit, I can figure out which oscillator coil or oscillator trimmer to just get that back in line. And I'll just do that for the FM. I'm not going to do anything else other than the dials alignment. So the very last adjustment I need to make is the overload protection adjustment on the power amplifiers. Each power amplifier has its own adjustment, and what it is, it's a trigger level. What it's doing is it's measuring the output voltage, and when it hits a threshold it triggers and it tells the power supply or whatever, the protect circuit, to kick in and shut down the outputs. Actually what it does is it turns the relay off. So the instructions are connect a 4 ohm load to one channel at a time, and in this case I'm doing this channel here, I think it's left, and you slowly ramp up the power until you hit 32 volts RMS, and that equates to about 250 watts on a 4 ohm load. Now once you get to that power level, you adjust this potentiometer just to the point where it trips, and you want it to trip right at that 32 volt. And then once you do that, you have to shut power off on the unit to reset it. So you shut power off, turn it back on, and then slowly ramp it up again, and then check and confirm the trip point is correct. So I'm going to do this here now. You're going to be able to watch it because I'm going to have my screwdriver here, but I'm going to put you up on the voltmeter so you can watch along. Here, I hope you can see that. It's not a great, I wish that thing was backlit. So anyways, let's turn up the volume. I'm going to have to shut it down first. I think I just tripped it. Shut it down, turn it back on, wait for it to kick in. There we go. Okay, let's start ramping it up. Okay, 28 volts. Seems like it's low, so I'm going to try that again. The volume control doesn't really work for doing this because it's a stepped volume control. You need to have a fine adjustment. So I'm going to put it up around 28 volts. Here we go. Yeah, I'll put it right there. And then I'm going to turn up the signal generator. Okay, 29. So we need to adjust this back some more. I'm going to turn this one down. Let's try it again. Keep going up. 12, 13. Oh. Am I turning the pot the wrong way? Let's reset this. Okay. Going up. Okay, that's 29 there. What's 30? Come on, 30. 31. We're almost there. Almost there. Do that one more time. Let's turn this down a little more. Okay. Let's bring it on. $31. Okay, there's 32. Let me turn it down a little bit. So it's at 32. Okay. So let me adjust this till it clicks. There we go. And then what we'll do is we'll test it one more time. I'll just use the balance pot to turn the left channel off, and then we'll reset, and then I'll bring it gradually back with the balance pot because their levels are all set already. Here we come. Hard to say. Let's try one more time. Seems like it's cutting off early. Oh. Okay. $31.7 there. We can go up a little bit on the signal. There. Yeah, I'm happy with that. I'm going to leave it alone. And I'll do the other channel. So, that's basically what you do. What I was doing is I was backing this off counterclockwise to give it more voltage, and turn it clockwise to turn down the voltage. So that's this potentiometer right here. Let's get a little warm. I'm going to cool my heatsink off now. Alrighty, so I'm wired in to do a power test. I got an 8 ohm load on both channels. Pretty standard affair. Got its scope hooked up. You should be able to see it. So let's turn it on. Let's see how this performs. Now I don't know if I'll get maximum power because it might want to kick off. So I'm going to ramp this up slowly. Ooh, there's clipping. try that again. Okay, clipping's right there. Let's go. Right there, I think, is maximum. So we've got 39.19 volts RMS. Let's let this go for a while. And we are consuming 650 some watts. Now we got full power here for over 7 minutes. I think it's doing pretty good. I have a fan on my resistive load here. It's getting quite hot. I'm going to shut this down because I don't think it's going to show us anything more. It is actually doing pretty good. So this heatsink got a fair bit hotter than this one, but then this one's hanging over the bench and it's getting full access to air, so I don't think there's any problem there. Yeah, this one's definitely warmer than this one is, but they're not so hot that I can't put my hand on it and hold it there for indefinitely. It's probably about 50 degrees C, and for 7 minutes at full power, it's a really good amplifier. Like, this thing can pump out the tunes all day long. So let's let it cool down here, and then we'll do some square wave tests. Okay, so here's a 1000 hertz tone. It's looking pretty good. Let's try bass cut. So here we go. Bass cut. Bass boost. Okay, treble cut. Well, still a little scratchy pot there. Treble boost. Okay. 15 hertz, or that's a 30 hertz filter and 15 hertz filter. It really doesn't have much effect at 1 kilohertz. High cut. Okay. $10 kilohertz. It's doing pretty good for 10 kilohertz. 18, 19, 20 kilohertz. Looks just as good as a 10. Let's keep going. Yeah, we're losing frequency response on one amplifier to the left. I wonder what that's all about. We are up at 43 kilohertz. But overall they're performing pretty good. That is 62 kilohertz. And measure the signal out of the preamp and see if we have that same discrepancy there. Or you know what, I can just do it with patch cords. I can put a patch cord here and separate the two, and then I can flip the patch cord from one channel to the next. I can see if this anomaly changes and goes to the other channel. Okay, so there is, if I switch left and right, makes no difference. Okay, shut this off. Let's swap these two and reverse the order of these channels. So I'm feeding the left into the right channel and the right into the left channel. I'm going to see if that changes. And there it is. You see it on the bottom is different. So there's something going on in the preamp. Let me try at a higher frequency. You see the difference between the two. So it's definitely not the power amplifier, it's something in the preamplifier section that's causing some attenuation or high frequency attenuation. Okay, well there it is, done. It's as far as I'm going to take it. I'm not going to investigate that little bit of discrepancy in the preamp because it is so high up the frequency band. I don't think it's going to be amount to a hill of beans difference between one channel or the next. I don't think it's going to be audible. I'm going to bench test this thing and I'm going to listen to it and I'm going to see if it sounds good or not. I have a feeling it does. I already know it will. But everything's tuned in. The only thing I'm not happy about is the soft start circuit. It kind of slowly gets in and the relay buzzes and then it clicks. And I think I need to drop the resistors. We have two 100 ohm resistors in parallel, and it makes a 100 ohm resistor for the dropping resistor of the mains. And I think that should be down around 75 or 50 ohms maybe. So I'm going to look at getting a couple of 150 ohm to 10 watt resistors to replace those 200 ohm resistors. And I think that will make it click in a little better, a little sooner, a little more spring in its life. Not that there's anything wrong with that, it just has that awful sound when the relay clicks in. It kind of makes that bzzz, and then it kicks in. But overall, quite a receiver. I tell you, it takes a lot of work to do one of these things and clean them up, and you know, and then yeah, of course you're going to have screw ups like I did. I had a couple here with the one with a tuning capacitor and the other with the cap in backwards. When you're doing a project of this scale, you're bound to have one or two mistakes. I'm not really worried about that. That's how you learn, right? So anyways, this one's done. I'm going to the covers are not ready because I haven't heard from my client yet. He took them and he took them from me and he took them to an automotive place to get resprayed. And he hasn't contacted me, so I'm assuming they're not ready yet. So I'm just going to leave it like this with no covers. I'm going to listen to it, going to enjoy it, and yeah, it's quite a beast. I don't even know where I'm going to set it up. I have no place to set this thing up because it's so huge. One thing we didn't really look at was the separation kit, and the separation kit is only just wires. So I'm going to actually pull it apart and get the separation kit going, and then I'll probably put this up on my desk, the head unit, and then I'll put the power unit down on the floor somewhere. It's out of the way so I don't stub my toe on it, and then I'll give it a listen for a few weeks and we'll see how it sounds. But until then, thanks for watching, and I hope you enjoyed this 3-part series, and take care, and we'll see you on the next one. Thanks for watching.